Hey guys, this is our recording for example 4 of unit 1 section 2.6, okay? Example 4. A manufacturer of a children's playpens makes a square model that can be opened at one corner and attached at the right angles to a wall, the side of a house. If each side is 3 feet in length, the open configuration doubles available area in which the child can play from 9 square feet to 18 square feet. Now suppose that we place hinges at the outer corner and allow for a configuration like the one shown in the next figure, figure 2. So what's going to happen is we would like to kind of open this up, okay, and make it into this right here. Part A. Build a model that expresses the area of the configuration in figure 2 as a function of the distance x between the 2 parallel sides, okay? So in this figure, it tells you what x is, and it says here x is the distance between 2 sides that are parallel. So here is x. So this is what we need to know, okay? So build a model that expresses the area. So let's talk about the area. Would you agree the area of figure 2 consists of 2 things, the rectangle and that triangle piece, once you open up this third side right here, okay? Well, let's talk about the rectangle. Well, this is the rectangle. It's going to be length times width or base times height. Doesn't really matter of what you want to say. If I know the area of that rectangle plus the triangle, then I could figure out the area of the whole box. Let me draw the triangle this way. Okay, so what I'm really trying to draw is take this triangle, draw it over here. So it's not really upside down for you to see it. Okay. First, we know, as you can see, this base right here is x. And it gave you a height right there. And it highlighted for you. See this h right here? That's your height. So we'll just draw that right there, and this is a right triangle. I can find the area of a triangle. Okay? And we also know a couple of things. We have sides of 3s. So these are both 3. Now, there are multiple ways of going about this, okay? So one of the way is, if I know the base, the entire base is called x, I can just use half of this. This is half of your x, okay? So with that in mind, then I can just say, okay, well, I need to find what the height is. Well, that's not too bad, because in a right triangle, which I'm really just using this piece, okay? And again, this is not the only way about solving this. I'm using the right triangle because in a right triangle, I know it's a squared plus b squared equals c squared, since I need to know what h is, okay? H is unknown. So let's figure that out. This is just a triangle. A squared plus b squared equals c squared. I will use a squared as a half x, which is the base, a squared. Then my height, which is h squared, which is b squared, and then c is 3 squared. That gives me 1/4 x squared plus h squared equals 9. Okay. I will need to solve for h. Okay. I will need to solve for h. So h squared equals, I will move the 1/4 x squared over, 9, take away 1/4 x squared. We will now take a square root to both sides. Normally, I always tell you, remember, there's a plus or minus every time you take a square root, but because height is a distance, and the distance is always positive, so I technically don't need to worry about the negative. But I will try to find the common denominator. So this is now 9 minus x squared over 4. I want to find the common denominator so that way my numbers are a little bit friendlier. So I'm going to make the 9 over 1. So h equals square root 36 over 4 minus x squared over 4, which is really now square root of 36 minus x squared over square root of 4, since it's, well, if you don't see why I went like that, then I'll do this. Over 4, which is now square root of 36 minus x squared all over square root of 4. So a nice simpler height would be square root of 36 minus x squared all over 2. So that's my height. Okay? And why do I need my height? Why do you think I need my height? Because I would need to find the area of the triangle. Okay. Now that we have the height, it's easy for me to find the area of a rectangle. Area of rectangle is going to be area equals length times width of the rectangle plus 1/2 times base times height. Well, length for this box, it's still, if this is 3, that's your height of the box, and then, or the width, and then this is your base. So if we know exactly what that is, we know this is x, okay, because this is x right here. So that is x. So we're going to go area equals x times 3, which is really 3x, equals 1/2. Your base is back to x, and your height, we just found it over here. So we're going to put it in here as square root of 36 minus x squared all over 2. Then let's make this pretty. Area in terms of x equals 3x. I'm going to multiply the constant out, so that's going to give you plus, oh, sorry, change this to a plus for me. I was supposed to carry that down. Plus 1/4 x times square root of 36 minus x squared. Now, if you want to make that a little bit prettier, you can even write like this. Area in terms of x equals 3x plus x times square root of 36 minus x squared all over 4. Either one is fine, okay? There you go. So that is the area in terms of x and only x. All right, now let's do the B piece and the C piece and the D piece, and I think we're done with this example. The B piece says, find the domain of A. Now, because your input is x, okay, domain is talking about what is the x can be. Well, let's think about this for a second. Would you agree the original box has this dimension right here of 6? So what's happening is it opens it up. Okay. So it opens it up to make this shape, to have a bigger plane area, just like in figure 2. So the most it can be is going to be 6. And obviously the least is going to be non-inclusive 0. Now, why is it that it can be 6? Why is 6 inclusive? 6 is inclusive because if I have this x value being 6, then I'm just back to my original shape of a rectangle. Now, if I move it, right, as I move it in, remember, this is movable. These sides are movable, so you're kind of pushing it in so that way you can make to connect this. Because if you don't move this 2 sides in, this right here will not connect. There's no way that you can make it slanted, okay, of 3, because it's still just 3. So this is 3. If you don't move it inward, then this right here will not connect, and that's not going to make your figure 2 playpen. So that's why you have to move it in a little bit. So the most it can be is 6, and the least is 0. Part C says find the area when your x is 5. So what that's saying is, okay, well, move this in a little bit. Instead of having this a total of 6, let's move it in to have that 5. And all you gotta do is plug in 5 for the area formula. So a of 5 equals 3 times 5 plus 1/4 times 5, and then square root of 36, 5 squared is 25. So I'm just gonna write it straight in. So this is going to be 15 plus 5 over 4, square root 36 minus 25 is going to be square root of 11. So is that the prettiest we can do it without using the calculator? Did it give us unit of measurement? Feet. So feet square. If you don't have a calculator, I'll take that. If you have a calculator, you can enter that in, and that's about 19.15 feet square. Okay. Normally, I would ask for both. Then part D says, graph it out. So you can use your calculator, or let me power up my decimals really quickly and tell me what the largest area is. So let me find my decimals, okay? Decimals. Let's find you. Okay, so I'm graphing 3x plus 1/4, so 0.25x, 25, not 4. Then times square root, let's find where that button is. Square root, where are you? There you go. Times square root of 36 minus x, and then square. Okay, well, let's see what's giving me. What's going on? Ooh, look at that. Okay, so as you can see, first, if I didn't zoom it out, it looked like a line, because we are looking for the largest area. There has to be some sort of a curvature. So the largest area is going to be this guy up here. Let's see what that guy is. Okay. All right, so the largest area is about 19.817 at when x is 5.584. Okay, so based on the graphing, and yes, once you have your algebraic formula, then you can just enter that into decimals or calculator and then find the maximum. And the decimal that we just saw gave me this point, 5.584, comma 19 point, what was that? Let's check again. 19 point something. Let's verify really quickly. Oh, come on, computer. 19.817. 19.817. All right, say that to myself a couple times. 19.817. What does that mean? This is the input, this is x, and this is technically y. But our y is not really y. Our y is really the area, because that's our output right here. So make sure you know what y represents. So, for what value of x is the area the largest after you graph it out? So what I would like for you to do is sketch it out first. X represents your, I believe, your base. And then y is your area. I don't need an exact curve. I just need you to do that sketch. Then answer the middle half. For what value of x is the area the largest? What is the largest area? Okay. The largest area is 19.817 feet square when x is 5.584 feet. You can write both answers using one complete sentence. All right, now the nice thing is that, remember, if you don't understand it, write your notes on the side of your notes packet and come to class and ask me, or just listen to the video one more time. This is the end of our notes.